Welcome everyone. In this video I will show an interesting product rule application, and I actually saw this method first by Richard Feynman. So the name is, which you probably have heard before, Richard Feynman. He's a very famous physicist, and as I said, I was reading and I couldn't find where I was reading it actually. I tried to find it for the video, but unfortunately I couldn't find it. But in one of his lecture notes somewhere, I came across this method of taking the derivative of a product, and I thought that it would be cool to share it with you guys. Now I don't know if he actually found this himself, but as I said, I learned it from him. So let's give credit to the man, okay? Now, what is the formula though? We will derive what the formula is, okay? Let's say that we have a function f of x, and this is a product of functions. Let's say it is h of x times g of x times, I don't know, a of x, b of x, and it can continue. I mean, you can have as many products as you want here, but let's just stop at 4, okay? And if we want to, so the question is, what is f prime of x? This is the question. And there is if you know the general product rule, you can directly write this. And when we come to the end of the derivation, you will see that we can derive the general product rule using Feynman's method. However, I don't think that, most people are really familiar with the general product rule. We know the product rule for the product of two functions, right? The derivative of the first one times the second function plus the derivative of the second function times the first function. That is the product rule for two functions. But what is it for 3 or 4 functions? Well, we will see what it is. And if you know it, well, good for you, but you can see where it comes from, which is very important. So, if we take the logarithm of both sides, we are going to have ln, let's say. Let's take the natural logarithm, and it doesn't really matter. But this makes it, makes it more neat, I think. So we take the ln of both sides, as we were saying. Let's write it step by step. And let me write it one more time, because there is an important step that we can take. If you have a product inside of a logarithm, you can separate it like so. ln h of x plus ln g of x, right? And you don't need to believe me. Why would you believe me, right? We are doing math, so there should be a way to check that this is correct. And I in fact have a video where I derived this, so I encourage that you check that video out from the cards right now, and also you can access it from the descriptions part. Okay? I really suggest that you check that video out, because, who knows? Maybe this is wrong. Who knows? But if you watch it, you will see that this is in fact correct. Okay. So if we take the derivative on both sides now, and how do we take the derivative of ln? It is going to be, so basically we are using the chain rule. So the derivative of the inside, which is f prime of x, and then it's going to be divided by the thing that is inside, f of x. Okay? This is the chain rule. Now, this is going to be equal to, similarly enough, sorry about that, it's going to be like this. Let me quickly write these. And then plus the last term. Okay. Now, as you can see, we are very close to finding f prime of x, which is what we're looking for. So to find it, we're going to multiply both sides by f of x, which means then that f prime of x is equal to f of x times all of these guys. Let's write them. It's going to take a long time, but let's just write it. Okay, so this is the way apparently Feynman takes derivative of a product. Okay? Now comes the general product rule actually, and that is, if you think of f of x as this product, which it is, then you see that f prime of x is equal to. So if you just substitute this here, and if you distribute it to the parentheses, you will see that for the first term, h of x will simplify and the others will remain, and there will be also h prime. For the second term, g of x will simplify, and then there will be the product of the other three times the g prime of x. So in fact, what we have then is h prime of x, g of x plus, well, you know what, I hope it is okay with you guys if I don't put x, okay? Let's think that it is implied that they are functions of x, but to have enough space, I will avoid putting x, okay? I hope this is clear. So f prime is then, and as I said, there is an x here, even though I don't write it. We are implying that these are all functions of x. The result is h prime g a h plus g prime, well, let's write it like this perhaps, h g prime a, and this is a b, sorry about that, yep, b plus h g a prime b plus well, h g a and then b prime. Okay, this is the general product rule actually. And I mean, obviously, if you have two functions, that is, how do you have two functions? Well, if these two are 1, let's say a of x is 1 and b of x is 1. If they are 1, if they are a constant function, their derivatives are 0. So this and this simplify. And if they are 1, these products, well, you don't need to write them. And you get this familiar product rule, h prime times g plus h prime times g plus h times g prime, okay? That's just a side note. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. So for that, please make sure to subscribe. And this is it. Hope to see you in another video. Until then, take care.